So here we have a lens, and that's it here, and we have an incident ray that's coming into the lens. If we're going to draw a ray diagram to show what happens as the light is refracted, we need to know one or two things. One of the first points we need to know is where on earth are we going to put this normal line. That's the line at 90 degrees to the surface that the incident ray strikes. To produce the normal line, we also first need to make a tangent at the point where the incident ray strikes the lens. And here it is, the tangent just here. Now that I've got the tangent, I can now draw my normal line, and that's got to be drawn at this point where the incident ray strikes the tangent, or also where it strikes the edge of the lens. So here we have the normal line just here now. So now we see we've got our incident ray coming into the lens. We've drawn a tangent at that point, which now allows us to draw the normal line. And all we do now is apply the same rules of refraction that we did to refraction of light in a square block. And the light gets refracted as it goes into the glass. In other words, in this case, it goes towards the normal line, so instead of carrying on along this line here, it bends closer towards the normal line until it reaches the other interface between the glass and the air, and then we do the same process once more. So this then gives us a tangent and another normal line, and now we can draw the refracted light as it leaves the lens. And here it is. But be aware that as we leave the lens and the glass in the lens at this point, we then go into air, which is around here, so the refracted light moves away from the normal line. If we draw another incident ray coming in at a different angle, you'll see, and if you apply your thinking to what's going on above, that this time the light still gets refracted, but in a different direction, and this is due to the curvature of the lens, meaning that the tangent is at a different angle. This now means that the light coming out of the lens is now converging onto a certain point that's only here, and we call this the focal point. So this shows us how a convex lens can work in focusing the light on a particular point. Don't forget that for any particular ray diagram there would be almost an infinite, well, there would be an infinite number of incident rays coming into the lens, all focused on the one point. So all that energy that's coming in from the left in my diagram is all being focused on this one point, and this is why we can use magnifying glasses to start fires.